and welcome to Algorithms Lesson 1. In these videos I will be showing you how to break down a problem and plan a solution. For your computer science GCSE, you need to be able to use computational thinking. No program, idea or concept can be realised without planning. Planning requires you to analyse a task and break it down into something manageable. In computing, we require computational thinking to manage this. In computational thinking, there is decomposition, abstraction, pattern recognition, and algorithms. Abstraction by definition is the process of filtering out and ignoring the characteristics of patterns that we don't need in order to concentrate on those that we do. So I like to think of it as looking at a problem from a higher level, a top-down view, looking at the whole problem and seeing which bits we need to focus on first. Decomposition involves breaking down a complex problem or system into smaller parts that are more manageable and easier to understand. The smaller parts can then be examined and solved or designed individually as they are simpler to work with. So if you was making a website, you would break down the problem into the login screen, break that down further into entering your username, encrypting a password and sending that off to a database. Then you'd focus on actually submitting the data and then transitioning to the next page of the website, breaking it down. Pattern recognition involves finding similarities or patterns among small, decomposed problems that can help us solve more complex problems more efficiently. So what it might be is, for example, if you was programming a robot to traverse through a forest, there may be a set path that means the robot has to go forwards, then left, forwards and left, forwards and left in a pattern. You would recognise that it's doing the same thing over and over again and think we could use a loop. Then we have an algorithm. This is just a series of steps to solve a problem. It's a blueprint to our program. If we can create very accurate flowcharts or very accurate pseudocode, a really good algorithm, it means that creating our programs themselves are going to be a lot easier. When we are planning our solutions, we need to think about how we want to tackle that problem. We need to decide what each of the parts of our system are, decide what steps will be involved, and measuring our success. Once we realise what we need to actually do, we can then start applying our knowledge of programming, our knowledge of computer science, to actually solve the problem itself. For the Eduqas exam board, they have pseudocode guidance. For this one, we have not very many commands to go through. I'll go through them now. So if you was going to declare a subroutine or a function if you're using Python, or a method if you're using Java, you would have to use the keyword declare. To then use the subroutine you've created, you need to use the command call, the keyword call. To declare an array, you need to use the variable name plus, in square brackets, the size of that array or list. To output, such as text, please enter a number, you need to use the keyword output. When creating a variable, you can just write the name of the variable. However, you need to define that data type. So a part of declaring a variable, the declaration phase, is setting the data type. For example, my variable is integer. My variable is string, character, boolean, whichever one you need for that task. To assign a variable, you need to use the keyword set along with its value itself. So set counter equals 0 or set counter to 0 would work in this instance. Selection is using if statements such as if, else, and end if. You'll notice that in the guidance it does not say else if. In this case you could just use if. When using selection or repetition, you need to enter at least one single space or tab in so it's indented to show which part of your code is a part of that if statement. Any annotations can be done with curly brackets, and any comments, if it's a Java program, you can use /**. When creating loops, you have a little bit more free reign. You can use a for loop by using for I equals 0 to 3. Piece of code, next I. You've got repeat a set amount of code until a condition. You've got do a set of code and loop. You've got do a set of code whilst something equals true or something is less than another number. And you've got while a condition, repeat the code. Now we've got to grips with the pseudocode itself. If you go over to lesson 2, we'll start looking at how we break down a problem and apply the pseudocode knowledge to actually solve a problem.